video, we are going to use the unit circle to evaluate tangents. So let's start with the unit circle because that's what we're going to be using to evaluate here. So here's my unit circle. Let me just kind of grab it and move it over a little bit. And so what we're going to be looking at is the unit circle has some distinct features. We've talked about this before, about the three different special triangles, the 30, the 60, and the 90. The 30, 60, 90, and the 45, 45, 90. So I'm going to do here, I'm just concentrating on trying to get that centered. And let me use this color here. So this is the 45, 45 triangle. It's like a little bit closer to there. This is going to be the 30, 60, 90. So 30, 60, and then 90 would be down here. And the last one, you guys get to see me draw these fantastic triangles, is the 60, 30, 90. All right, there's something unique about this. So we do start our triangles, or we do start our unit circle at 0, 1, 0, 1, 0, and we end at 0, 1 in the coordinate plane. So this point right here is 0, 1, this is 1, 0. Well, this point right here is going to be the square root of 3 over 2, 1 half. So this point in the space of the coordinate plane is at the square root of 3 over 2 and 1 half. This point right here is the square root of 2 over 2 and the square root of 2 over 2. Which means that this is cosine of pi over 6. This is pi over 6. Cosine of pi over 6 is square root of 3 over 2 and 1 half. Cosine is square root of 3 over 2. Sine is 1 half. Here, this is pi over 4, or 45 degrees. My cosine of pi over 4 would be the square root of 2 over 2, and the sine of pi over 4 would be the square root of 2 over 2. And then this last point, this is going to be 1 half, the square root of 3 over 2, and this is for your pi over 3's. So your cosine of pi over 3 is 1 half. Your sine of pi over 3 is root 3 over 2. This actually follows, this pattern follows all the way around. This reference angle is pi over 6, which means that this is going to be the square root of 3 over 2 and 1 half. The only difference here with this reference angle is that we are in quadrant 2. So we are in quadrant 2. And being in quadrant 2, we can see that my x values are going to be negative, but my y values are positive. So this x value will get a negative. So we're looking at negative root 3 over 2. This is still going to be the same. This is the reference angle because this angle from here to here is pi over 4. Even though this is not, this will still be root 2 over 2, root 2 over 2. But because we're in quadrant 2, this would be a negative root 2 over 2 because my x values are negative. And we follow that all the way around the unit circle. As long as you're pi over 6 away from the x-axis, you're always going to be a square root 3 over 2, 1 half. The sign depends on the quadrant. So in quadrant 3, sine of theta will be negative, cosine of theta will be negative. In quadrant 4, sine of theta would be positive, while will be negative. Well, cosine of theta would be positive, and I know I moved that over from where it originally was, and I might have lost a little bit of my edge. All right, So this goes around, it's the same values. Again, we use the x-axis for our reference triangle. And so this allows us to kind of get some of these values. All right, so nice writing. If you need to pause and write it down, go right ahead. I'm going to delete it all, and we are going to look at the problem at hand. The problem at hand, we have tangent of negative 5 pi over 6. When we have a negative, that means we're going in the clockwise direction. All right, so this is 0. This is negative pi over 2. This is negative pi. So if I'm looking at this, 5 pi over 6, if I added one more pi over 6, I would get 2 pi. So I'm going to say that my angle is about here. And again, we get our reference angle off of this guy. So I'm going to do pi minus 5 pi over 6, because we're just about that far away, 5 pi over 6, which is pi over 6. So my reference angle is pi over 6, and the reference angle comes into play because then again, if I were to look at this first coordinate, I remember that this is the square root of 3 over 2, 1/2. And so since this is the same reference, just 180 degrees, this is going to be negative 3 over 2 and 1/2. All right, so what do these numbers mean to me? Well, this number means that sine of negative 5 pi over 6, and these are both negative, is equal to negative 1/2, because we're in quadrant 3. This also means that cosine of negative 5 pi over 6 is going to equal negative root 3 over 2. All right, so knowing that, I also know that tangent of negative 5 pi over 6 is going to equal sine negative 1/2 divided by cosine negative root 3 over 2. All right, cleaning this up, simplifying it, the 2's would cancel out. We are left with 1 over root 3. We do have to rationalize the denominator, so I'm going to multiply root 3 to both bottom and top. And we are left with the root 3 over 3. So the tangent of negative 5 pi over 6 is equal to root 3 over 3. All right, so that unit circle that I drew at the beginning of this example, that is really great to memorize. I've said this before when we went over the special right triangles in the unit circle. It's great to memorize those numbers because that shows up literally. It repeats itself as you go around the unit circle depending on the reference angle. Let's see, there's another example. So we're going to look at another example. I just said that. That is tan 3 pi. So tangent 3 pi. So in this case, we're positive, so we're going in the counterclockwise. Here's 1 pi here. Right here, we're going to go, so this is 1 pi. Then this piece right here is 2 pi. And we go around one more time, and that'll be 3 pi. So we actually end up in the same spot. It's almost like you're running around a track and you end up in the same spot. So this can actually be tangent of pi. They are the same. And tangent of pi, remember this is the radius of 1, so this point right here is going to be x1, y0. And therefore, we have tangent of pi is equal to sine of pi divided by cosine of pi, sine being the y, this being the x. So we get tangent of pi is equal to 0. Oh, this is a negative 1 because we're in the negative direction, and negative 1, which is going to be 0. Therefore, 3 dots for therefore, tangent of 3 pi, which is the same position on the unit circle as tangent to pi, is equal to 0. All right. One last one. Let's look at tangent of negative 3 pi over 2. So we're again negative. We're going to go in the clockwise direction. This is pi. This is 0. Pi over 2. Pi. And this is all negative because we're going in the clockwise direction. And this is negative 3 pi over 2. So my point is right here. I can now write this as this again in the positive direction. This is going to be tangent of pi over 2. Tangent of pi over 2 is 0, 1, because again this is x equals 0, but y is equal to 1. Again, it's going to be sine pi over 2 divided by cosine pi over 2. Y divided by x, and that means we have 1 divided by 0, and this is a sad face because you cannot have a 0 in the denominator. Therefore, tangent of negative 3 pi over 2 is undefined. Okay, so again, memorize that unit circle. It is, you can find it both in degrees and radians. You can find them on Google. They're abundant. They're there. Usually I'd print them out. We would have quizzes on these things for you guys to memorize. Make sure that you memorize this unit circle. All right, so if you have any questions, please always feel free to ask, and I will catch you in the next video.